Now we will see the circular doubly linked list. Circular doubly linked list. Okay, here how is circular doubly linked list represented? We'll see that. So let there be some doubly linked list like with data 10, 20 and 30. Imagine the first node is at 1000, second node at 2000 and third node at 3000. So here we'll just start with this first node's right link. Okay, right link it will be 2000. So there will be a connection like this. Here it will be 1000. There will be a connection like this. Here it will be 3000. So there will be a connection like this. Here it will be 2000. And now here circular doubly linked list means this portion should be connected to the first node. So here the address will be 3000. So here it will get connected, and here the address will be the last node, address of the last node, which is 3000. So this will be connected like this. So this is a circular doubly linked list. It's looked like a circular, and here we have the first having the address 1000. Okay, so now we are going to insert at the end, insert at the front as well as at the end of the circular doubly linked list. Again we are going to delete from the end and delete from the rear and circular circular doubly linked list. Okay, so we can see how to insert at the void insert front of the circular doubly linked list. Okay, so as I said, insert we have to see two cases: when the linked list is empty, and second thing when there are many nodes. So this follows for all the insertions. So first we have to what we have to do, we have to create temp. In insertion we have to create temp. Imagine I'm going to create a node called 10. Okay, let it be at 500, and this will be null and this will be null. Here left link is null, right link is null, let this be temp. So this is the node I want to create. How do you create it? We'll do temp struct node star, it's mlog struct node size of struct node. Okay, so temp will be created. After that we can put into temp of data 10 and make its R link as null. Similarly, left link, temps left link as also null. Okay, so then what we are going to do is, imagine the first case. Imagine the first case. What was the first case? Linked list is empty. We know if the linked list is empty, if first is equal to null. So if it is null, what we have to do, we have this 10 data in our hand, this which is temp at 500. So what we have to do is, here because this is circular doubly linked list, this side should point here and this side should point here. Okay, and we have to make our first here, that is 500. So these are the changes we have to do. So what we have to do here is, in temp of R link, okay, it is going to point to temp itself. Even temp of left link point to temp itself. And then what you have to do, first which was null, you have to make it, first was null. Okay, now you have to make this as 500. How to make it 500? 500 is the value of temp. So you can write first is equal to temp. So these are the things you have to make during the first case. That is when your circular doubly linked list is empty. Similarly, we'll see we'll see if it is going for the second case, which is uh, else, which is there are many nodes in the linked list and you have to insert. Imagine there are nodes like 20, 30 and 40. Okay, and your aim is to insert this 10, which is here null, the name is temp, so at 500 this should be inserted at the front. Okay, so imagine this is at 1000, this is at 2000 and 3000. So here we will write 2000, so there will be a connection. Here we will write 2000, here it is 3000 and here it is 2000. Now this one will be 1000, so there will be a connection like this, and here it will be 3000, so here it will be a connection like this, and your first will be 1000. So what are the changes you're going to do here is, now you want to add this. The changes you are going to do here is you want to add this to the first node. Okay, to add this to the first node, here the address should be 1000. Okay, and here the address should be 500. Okay, after that what you have to do, after that this address will be changed to 3000. Okay, so there will be a connection like this, and this address will be changed to 500, so there will be a connection like this. Okay, and your first will come here to the temp node, that is first should be 500. So in short I'll just we'll just see the answer of it, so it will be easy for us. So in short, the answer should be like this. 10 should come first, then 20, then 30, then 40, and finally this should be connected here, this should be connected here, and all this has connections, and first will be changed, first will be here now at temp. This is what we want. So let's see the code, how this is going. So first what we will do, we have to make some changes at the last node. Okay, we have to make some changes at the last node. So what we are going to do, we are going to give a pointer variable called last here. How to do that? Now if you want to point last, that means from null you have to make last as 3000. How to make it as 3000? If you say this value is 3000, that means first of left link. Okay, first of left link is 3000. So first you do that. Okay, so last is equal to first of left link. Okay, now last is pointing here. Okay, after that now you start connecting it. Okay, so now we'll say temp of our link. So here I'm going to make it as 1000. So how to do that? Temp of our link, I want to make it as 1000. Okay, so 1000 is where that value is there in first. So I can automatically write temp of our link is equal to first. Okay, now that is done, so there will be a connection like this. Okay, now what you have to do is you have to get a connection of like this also. From this should be moved. Okay, with this value here, instead of 3000 it should become 500. That means your first of L link should get the value 500. Now 500 is temp. Okay, so you can do first of L link is equal to temp. So what will happen? Here 500 will come. Now what you can do is, now you can change this one. Okay, this one you can change. This one should be pointing to where? It should be pointing to temp. It should be pointing to temp. So what you have, what is happened? Last of R link, okay, should be equal to 500. That means this should be moved. We get 500. Okay, so this is what I'm going to do. This one, this part, which is 500 here. So how to put 500? Last of R link is 500. That means it is temp value. This 500 is actually temp. Okay, so you can put last R link equals temp. Similarly, now only temp of left link is left. Okay, we didn't change this one's value. This value, it should be becoming what? It should become 3000. That is here. This should become 3000 so that there will be a connection like this. So how will you do that? To write temp of, this is temp of uh, left link, you have to make this as 3000. 3000 value is present in last. Okay, so what you can do is here temp of left link is equal to last. Okay, and finally we have to put first where temp is pointing to. Now first is pointing at 1000. We have to make it as 500. How to make first as 500? We can write it like this, correct? No, first is equal to 500. 1000 is moved and it changes to 500. So 500 value is present in temp. So I can say, right, first is equal to temp. So so we'll get the answer like this. So this is the this is how to insert the front of circular doubly linked list. So when we are going to insert the end of the doubly linked list, always the code till this much code will be the same. Okay, so I'm not going to repeat that. I'm just going to put the else part, that is for the inserting at the end of the doubly linked list. So let's see that. Void insert at the end of the doubly linked list. So all the code remains the same till else. Okay, else. So here else, that means that is the second case where we have more number of there are some nodes in the linked list. So let's see how this will happen. Suppose you consider this case where you have 10, 20 and 30. Okay, you want to insert 40 at the end. This is null, this is null. Imagine this is temp, which is at which has the address 4000. You have to insert at the end. So let this be 1000, 2000 and 3000. So what we're going to do here it will be 3000 as this is circular doubly linked list. Here it will be 2000 where there will be a connection, 1000, here 3000, here 2000, here 1000, like this, and here it will be a connection like this, and first will be as 1000. Now you have to add this to the end of the circular doubly linked list. So what are the changes here? What will happen? Instead of 1000 it should become 4000. So we have a link like this. Okay, and here it should be 3000. So we have a link like this. Okay, so now here what should happen? Here it should be 1000. So we are going to have a link here. Okay, and then what should happen? Here I have to remove 1000, 3000 and should make it as 4000. So here I will have a link like this also. Okay, hope you understood. Let's see what are the changes. Okay, now what we are going to do is first um, first we have to make this as last. How to make this as last? So last was null when initially it started. Now it should become 3000. So last should become 3000. Where is this 3000 present? This 3000 is present, the value is present in first of L link. So you can say last is equal to first of L link. So you can write last is equal to first of L link. Okay, after that what you have to do, you change your last of R link. This should be 4000 now. Okay, that is your last of R link was 1000. You're going to change it to 4000. Where this 4000 is present, this number is present in temp. Okay, so you can write last of R link is equal to temp. Okay, now so there will be a connection like this. Now you can change temp of left link. Here left link should be 3000. Okay, so temp of left link it should be 3000, and 3000 data, that number is present in last. So I can make temp of left link as last. Okay, so now I should change temp of R link. So this is already done. And now our R link should be changed to first. Correct? No, first means the 1000 should come. So that means temp of R link should get the value 1000. So this 1000 value, it is present in first. You know that it's present in first. So what we have to do is temp of R link is 1000 means that is the value of first. So we can write temp of R link is equal to first. Now only one more change is there. What you have to do is now you have to change this value. Okay, this value should be temps value, which is 4000. That means first should become 4000 now. First left link should be 4000 now instead of 3000. Where is this 4000 present? In temp. So you can directly write what first is equal to first left link is equal to. So this is the code for the inserting at the end of the doubly circular linked list. Now we'll start with deletion of a circular doubly linked list. And here also we have two types of deletion from the front and deletion from the end. Okay, so first we'll see the deletion from the end, deletion from the first. Deletion from the front. So as I told you, for deletion we have three cases. Linked list is empty. Second one is linked list has only one node. Then third thing is linked list will have many nodes. Okay, so when we start for the first case, so imagine this is void delete front of a circular doubly linked list. Okay, so you know if linked list is empty, the condition is first is null. If your first is null, you can say there is no nodes to delete. Printf no nodes to delete. Okay, now imagine you have the second case. Your second case is else. So if I can do an else and put this one in if and this one in else. That means inside else I have if else. Okay, so what I'm going to do is my second case if. Okay, How do you know that there is only one node? Imagine there is only one node in the circular doubly linked list. So how will the circular doubly linked list look? Here that will be first. Imagine this is at 1000. So here this R link will be pointing to itself. Also the left link will be pointing to itself. Okay. So this will be 1000. First will be 1000. So how can I say there's only one node in doubly linked list? When you see the R link, you can take the R link or L link. It will be pointing to first itself. That means your first R link will be pointing to first itself. If there is only one. If in such case there is only one node. So what you are going to do is you are going to make temp as this node. Okay, which temp is null now. Temp is made into temp was null. Now you are making temp as 1000. This 1000 is present in first. So make temp is equal to first. After that, what you will do, now you have to delete the whole node. This whole node should be deleted. Before that, you print the data. Print the deleted element is %d, and you can write temp of data. Okay, so temp of data is printed, and that is 10 is printed. After that, you can use the free function. Okay, free the temp, and after that finally you have to make your first as null. Okay, so here what you do is you have use free temp to free it. Now your free first is 1000 itself. This node has gone, so you have to make your first as null. So that is what the last code I did. Okay, so now we will go for the else part. Else part means there are many nodes. Okay, there are many nodes, and what is the condition? Okay, there are many nodes. For example, imagine your condition is this: 10, 20, 30. Okay, this is at 1000, 2000, 3000, and here it will be 3000 because this is a circular doubly linked list. Here it will be 2000, here it will be 1000, here it will be 3000, here it will be 2000, here it will be 1000. So here there will be a connection. This one will be connected like this, and your first will have the value as 1000. Okay, now what you're going to do here is, what are the changes you have to, the changes you have to delete the node from the front. This node you have to totally delete it. Okay, and here what is the change going to happen? Here now the first will come here. First will come here, correct? First will become 2000 now. And here what it will become? This will become 3000. Okay, that means we from here the node is going to get connected here, 3000. So now this will move, this will get the value 2000. That means this will be connected here. Sorry, if you write 3000, this will go and connect it here. So both of these connections are done. So okay, so we'll just look through to this what we can do. Okay, now what we will do first is you have to make this as temp. Okay, so if you have to bring temp here, what you have to do is temp which was null is made to 1000 now. This 1000 value is present in first, so you can put temp is equal to first. Okay, then what will you do? Your first you have to move from here. First, which is 1000 now, you have to move it to 2000. So where is this 2000 present? This 2000 is present in temp of R link or first of R link, anything you can use. So I'm just going to use here temp of R link. Okay, so now your first becomes temp of R link. When you do this, what happens? It will take the value 2000, put it into first. Now your first is going to move here with the value 2000. Now what you're going to do is uh, now you have to make some changes here, correct? So you have to you have to give a name for this node also. So I have to name the node 3000. For example, let it be last which was null should be made to 3000. So this 3000 value is present in temp of left click. Okay, so I can write last is equal to temp of left click. So what happened? Last comes here. Okay, and now what you have to do is, now you're going to change this and make it into 3000. And so how will you do that? That means your first of left link should be 3000. So 3000, this value is present in last. So you can just write it as first of left link should be made as last. Okay, now you go to this one. This it should be 2000. So last of R link should be 2000. So how to make it 2000? This value is present in first, correct? So you make it last R link is equal to first. Okay, now our aim is to delete the temp. Before deleting the temp, bring the data. Printf, the deleted item is %d temp data, and then you can free your temp. So this is this is the deletion at front of a circular doubly linked list. When you see deletion from the end of the doubly linked list, till here the code will be the same. Till here the code will be the same. So let's see the else part. Okay. Let's see the else part for delete end of circular doubly linked list, and all this the same, else I'm going for that else part. So else means there are many nodes in the linked list. So let it be 10, 20, 30, and let this be 1000, 2000, 3000. Here it will be 3000. So there will be a connection like this, and here there will be 2000, 1000. Here it will be 2000, and here it will be 1000. Okay, and first will be here, which has the value 1000. Okay, now how we are going to do this is we are going to delete a node from the end of the circular. This is what you have to delete. Okay, so what you're going to do here, you're going to so here before deleting this there should be a change here. So this should be 1000 now. So this will point here, and this will change into 2000. So this will be here. Okay, and so these are the changes which are going to happen. So let's see how to do this. Okay, now we have to name this because this one is what we are going to free. So we have to name this. So I have to let me take it as last. Okay, last should be 3000, which was null should be last. I have to put it here. So this 3000 value is present in first of left link. So I can write last is equal to first of left link. So last comes here, and after that you have to make changes in this node. So I also have to point to this node. Okay, I need a name for this node. So I'm taking it as previous. So previous should be 2000. This 2000 value I can write, it is present in last of left link. So you can write previous is equal to last of left link. Now you can say, now I want to change this into 1000. So how do I do that? That is, this now is my previous. So previous of right link, I have to make it as 1000. This 1000 value is present in first. So I can write previous R link is equal to first. Okay. Now that is done. So 1000 means it will get connected like this. Now I have to change this. That means my first of left link I have to change from 3000 to 2000. Okay. So I have to change to 2000. This 2000 value is present in previous. So I can write it as first of left link is equal to previous. Okay. And after that, now I can delete this. This is no more. I need no more. So before doing free, you just print the data. The deleted item is %D last of data. Okay. You do last of data. After that, you can free your last. So this is the code for circular doubly linked list where you delete from the end. So thank you.